Mercury, the closest planet to the Sun, is the smallest of the 8 recognized planets in our solar system. Named after the Roman god of commerce and travel, it has been known since ancient times due to its brightness and rapid movement across the sky. Ancient cultures, such as the Greeks and Romans, saw Mercury as the messenger of the gods, moving quickly due to its short orbit around the Sun. Mercury's unique environment has made it a focus of scientific interest, especially in the last few decades. Physical characteristics of Mercury. Mercury is the smallest planet in our solar system, about 1/3 the size of Earth, with a diameter of about 4,900 kilometers, 3,000 miles, which is about 38% of Earth's. Despite its small size, Mercury is quite dense, with a large metallic core estimated to make up about 85% of the planet's radius, leaving a relatively thin mantle and crust. Mercury's surface is covered with craters, plains, and unique geological formations. Its craters are similar to those seen on the Moon, formed by intense impacts from asteroids and comets early in the solar system's history. The planet is known for its lobate scarps, or cliffs, which are massive and stretch for hundreds of kilometers across the surface. These scarps were formed as the planet cooled and contracted, causing the crust to wrinkle. One of the most prominent features on Mercury is the Caloris Basin, a massive impact crater over 1,550 kilometers, 960 miles, in diameter. This basin is one of the largest impact structures in the solar system and shows signs of volcanic activity. Temperature extremes. Mercury experiences the most extreme temperature variation of any planet in the solar system. Due to its proximity to the Sun and lack of a significant atmosphere to retain heat, surface temperatures can soar to about 430 degrees Celsius, that is 800 degrees Fahrenheit, during the day, and plunge to -180 degrees Celsius, -290 degrees Fahrenheit, at night. This extreme fluctuation is due to its slow rotation and thin atmosphere, which allows heat to escape quickly after sunset. Mercury has a very thin atmosphere, or exosphere, composed primarily of atoms that have been blasted off its surface by solar wind and micrometeorite impacts. Elements detected include hydrogen, helium, oxygen, sodium, potassium, and calcium. This exosphere is constantly being replenished as particles are stripped from the surface, and because of the weak gravitational pull, it is also constantly escaping into space. Despite its small size, Mercury has a magnetic field, though it is only about 1% as strong as Earth's. Scientists believe that its magnetic field is generated by a dynamo effect in its partially molten metallic core. Mercury's magnetic field interacts with the solar wind, creating a magnetosphere that, while weak, can still protect the surface from some solar radiation. However, this interaction with the solar wind causes intense magnetic storms on the surface. Orbit and rotation. Mercury is the closest planet to the Sun, with an average distance of about 58 million kilometers, 36 million miles. Its proximity results in an extremely short orbital period. Mercury completes one orbit around the Sun in just 88 Earth days. Mercury has a highly elliptical orbit, with distances from the Sun ranging from 46 million kilometers, 29 million miles, at perihelion to 70 million kilometers, 44 million miles, at aphelion. This elliptical orbit means that Mercury's speed varies, moving faster when it is closer to the Sun and slower when it is farther away. One of the most interesting aspects of Mercury's movement is its 3:2 resonance rotation. It rotates 3 times on its axis for every 2 orbits around the Sun. As a result, a single day, sunrise to sunrise, on Mercury lasts 176 Earth days. This unusual rotation pattern means that if you were standing on Mercury's surface, the Sun would appear to rise, stop, reverse course briefly, and then continue its path across the sky. Mercury's discovery and exploration history. Mercury has been observed by various ancient civilizations, including the Sumerians, Babylonians, Greeks, and Romans. Its rapid movement across the sky made it a notable celestial object, and ancient observers realized it was a distinct planet. The Greeks called it Apollo when it appeared in the morning and Hermes when it appeared in the evening, reflecting its dual visibility and rapid movement. Modern space missions. In modern times, our knowledge of Mercury has been greatly expanded by space missions. NASA's Mariner 10 mission, 1974 to 1975, was the first to visit Mercury, providing the first close-up images and revealing a surface similar to that of the Moon. More recently, NASA's Messenger mission, which orbited Mercury from 2011 to 2015, mapped nearly the entire surface, studied its magnetic field, and made significant discoveries about the planet's composition. The Bepi-Colombo mission, a joint endeavor by the European Space Agency and the Japan Aerospace Exploration Agency, launched in 2018 and is en route to Mercury, with plans to study its magnetosphere, surface, and interior structure in greater detail. Key discoveries from Messenger. One of the most surprising discoveries made by the Messenger mission was the presence of water ice in permanently shadowed craters at Mercury's poles. Despite Mercury's extreme daytime temperatures, these craters are shielded from sunlight, allowing ice to persist. Along with water ice, Messenger found evidence of complex organic molecules in these polar regions. This discovery has implications for understanding the distribution of organic materials throughout the solar system. Messenger's data revealed that Mercury was geologically active for much longer than previously thought. Evidence of volcanic plains and tectonic features suggests that volcanism shaped its surface well after its formation. Mercury's role in planetary science and astrobiology. Studying Mercury provides insight into planetary formation processes. Its large iron core and thin mantle challenge traditional models of planet formation, suggesting that it may have experienced significant impacts that stripped away much of its outer layers. Understanding Mercury's formation helps scientists refine models of rocky planet development, which can be applied to the study of exoplanets in other solar systems. While Mercury's environment is too extreme to support life as we know it, the discovery of organic materials and water ice at its poles raises questions about how these building blocks of life are distributed throughout the solar system. The future of Mercury exploration. The Bepi-Colombo mission, which is expected to enter orbit around Mercury in late 2025, will add significant knowledge to what we know about the planet. Equipped with advanced instruments, Bepi-Colombo will investigate Mercury's composition, interior structure, and magnetic field, expanding our understanding of the planet's geologic history and its interaction with the solar wind. This mission represents the next step in unraveling the mysteries of Mercury and will likely offer more insights into the broader processes of planetary evolution in extreme environments. Mercury, the innermost planet of our solar system, holds many unique features and mysteries despite its small size and proximity to the Sun. From its extreme temperature fluctuations and ancient cratered surface to its surprisingly strong magnetic field and polar ice deposits, Mercury has proven to be a much more complex world than once thought. With upcoming missions like Bepi-Colombo, we are poised to learn even more about this intriguing planet, shedding light on the origins and evolution of terrestrial planets and enhancing our understanding of the early solar system. Mercury's study not only enriches our knowledge of the planets close to home, but also informs the search for exoplanets and the study of planetary habitability on a cosmic scale. As a world of extremes, Mercury remains a key to unlocking the secrets of planetary science.